Lesson 103 has two parts. The first part is on powers of negative numbers, and the second part is on dividing terms. Now, we're not talking about negative powers. We're talking about powers of negative numbers, like negative 2 to the third power. Think about what that means. We're multiplying negative 2 3 times in a row, right? Now we know what happens when we multiply two negative numbers together. That equals a positive. So negative 2 times negative 2 is a 4, right? Multiply that by that third negative 2 and we get a negative 8. Now watch when we do negative 2 to the fourth. That'll be 4 negative 2's in a row. Just multiply these in pairs. Negative 2 times negative 2 is 4, times the other negative 2 times negative 2, which is also 4, equals a positive 16. Let's do one more just for an example here, just to help you understand what's going on here, and then to understand the little rule that we're going to talk about. Negative 2 out 5 times, think about that. Now let's speed this up a little bit. We already know what negative 2 4 times in a row is. That's 16. Then multiply it by that fifth negative 2. We get a negative 32 for an answer. Do you see the pattern that's happening here? When we have a power that's odd, our answer is negative. When we have a power that's even, we have a positive answer. So there's a little rule that you can remember when you're working with powers of negative numbers, not positive but negative numbers. If you have an odd power, the answer will be negative. Likewise, if you have an odd number of negatives that you're multiplying together, you'll get a negative answer. If you have an even number of negatives that you're multiplying together, you get an even, or not an even, a positive answer. Look at practice problem A. I just want you to simplify that. And what you should do when you have a bunch of factors multiplied together there is just count how many negatives you have. And you can see you have 3, so you know your answer will be negative. Just go ahead and write a negative down here, and then that's pretty simple multiplication, so just do that in your head. 2 times 3 is 6, times 4 would be 24, and then just times 1 is 24, times 2 is 48. Negative 48 would be the answer. Whenever you're working with negative values, that's always a thing that can cause some error, is keeping up with that negative sign. So looking at the problem first and counting up all of your negative factors, that tells you if your answer will be negative or not, and you can just go ahead and write down a negative sign or not a negative sign if it's an even number of negative factors. And that helps you keep up with that negative sign. Let's do a few more. Look at B, C, and D. Why don't you just pause the CD and work on those. So on B, look at your power. You have an odd power, so you know your answer will be negative. And it's just 1 times 1 times 1, which would be 1. So that's negative 1. Look at C, an even power, so we know our answer will be positive. Negative 9 times negative 9 is a positive 81. And then D, we have an even power again, so we know our answer will be positive. Negative 3 times negative 3 is a positive 9, and then doing that again would be another positive 9. So this is also a positive 81. If we have an even number of negative factors or an even power to a negative number, then our answer will be positive. If it's an odd power or an odd number of negative factors, our answer will be negative. Now let's talk about dividing terms. This is the second part of the lesson, and let's just learn about this by doing some practice problems. What you should do to divide terms like this is break them up into individual factors. For example, x squared, make that x times x, and y squared, y times y, and so on. And then you can see clearly what you need to cancel. So let's just go ahead and do this on this practice problem. We'll have 4x, x, y, y, z, z. Sometimes I put a slash in the middle of the z so it doesn't look so much like a 2. And then 2x, z, z. Now it's easy to see what factors you have in common in the numerator and denominator and those that you can cancel. You can cancel one of the x's, both of the z's. And then the 4 and the 2 will turn into a 2 over 1. Now you can go ahead and simplify this. 2 x y y, or just y squared. That's the result of that simplification. So in your homework set, they'll ask you to simplify relationships like that, and that means to cancel the things that you can. Usually, but not always, you'll just end up with one value. You won't have a fraction left. Let's do f, 9xy cubed over 3x squared y squared. Why don't you pause the CD and see if you could figure out how to do that one. First, write it as individual factors, 9xy, y, y, over 3x, x, y, y. The 9 and the 3 can reduce to 3 over 1. Cancel one of the x's and 2 of the y's. So this one we end up with 3y over x. Have a fraction on that one. So you don't always just get one single value. A lot of times, sometimes you will get a fraction. It just depends on the relationship. The goal is to simplify it though, and that means to reduce it to its lowest terms. It's just like working with fractions. If you want to simplify a fraction, that means reduce it to its lowest terms. That's what you're doing here too, except you have numbers and letters to deal with. Let's do one more. Simplify this expression. So we'll just write it out. 14abc over 21cb. Our b's will cancel. One of the c's can cancel. And then 14 over 21, there's a common factor of 7 there. So we end up with 2 over 3. And that gives us 2a over 3c. That's our answer. Unless you're a mathematics teacher or you go into engineering later, you may not use things like this very often. So the goal for you in understanding a problem like this is to develop good problem-solving skills, develop skills of being organized and neat, keeping up with your work, and applying the tools and the rules that you know to help you solve the problem. And those are skills you need anytime in life. Okay, well that's all for lesson 103.